To this focus group. We're going to make a start now, and let's get cracking. This is the focus group about expressions, and the title for this focus group is on the screen there. And I'm going to start with a slight apology that I misheard Mel when she said that I had 50 minutes to present on everything you want to know about expressions. I thought she said 50 hours, so I could tell you everything you could possibly ever want to know about expressions. So we had to adapt the title slightly to nearly everything you want to know about expressions. And this topic is an extremely broad topic, and we are going to attempt in the next 45 to 50 minutes to tell you a lot of things about expressions, but at the same time we're also going to point you to a load of resources for learning more about things, the topics we cover within this focus group. A little bit about me: I spend my time developing analytics features for FastStats and also using those analytics features on publicly available data sets and writing about them on the Apteco blog series. So, before we get cracking into the meat of the talk, I just want a couple of quick administration matters. This talk, and indeed all of the other focus group talks, are being recorded so that you can return back to them afterwards, or indeed you can go and look at all the other focus groups that you could have chosen as well. You should all be muted, but if you can make sure that you are, that would be fantastic, so that we don't get any interference. In terms of providing questions, if you have any questions during the session, please add them into the chat window, and my colleague Tim will either try and answer them in the chat window during the talk, or he will raise them at the end of the talk on your behalf at the end. He will also be posting during the talk, as I cover particular sections, links to extra resources as well on some of the topics that we cover. If you want to send questions after the session, then we'd always love to hear from you on topics from expressions, or in fact any other analytics topics. I'd love to hear from you. You'll get my email details at the end of the talk. So let's have a little bit of an introduction to the talk as a whole. The little joke at the start was really a way of saying, well, we can't just cover everything about this topic in this period of time. So what we're going to try and do is, it's going to be technical. We're going to show you something about the basics of expressions, so that for those of you who have never used expressions before, who are new to the software, we'll show you a little bit about how they're used in the most simplest cases. But then they're going to escalate into showing you some more advanced features, different data types, different things we can add into expressions, and ways in which we can utilize the software for many different marketing analytics use cases. And we're going to try and show you a whole breadth of things. We're not going to go deep into any particular area, but just if you find that something there you're really interested in, we can show you more resources on that particular area. So if you know a little bit about expressions, then hopefully we'll improve your education during the next 45 minutes. And if you think you know everything about expressions, well, maybe in 45 minutes time, you can reevaluate whether you do indeed know everything there is to know about expressions. We will show you some of the developments that we've made in the last calendar year. For those of you who are running software releases that are a few behind where we're at now, so I can show some features that will be coming up soon. And it's never a focus group talk if we don't sort of give you a sneak peek into sort of some of the R&D work that's actually going on at the moment, and features that we'll hope to introduce to you sometime in 2022. Now, this kind of almost provocative quote here is put up to say, well, expressions allow us to do an awful lot of powerful things within the FastStats analytics arena. And I will use these all the time. Questions come to me, problems I'm trying to solve generally are the harder ones that we're trying to achieve within the software, and therefore I find that expressions are a really good way in which to unleash that power of the analytics engine. Alluding back to the previous topic of it, there's a huge topic here. There are over 200 functions available within the expression tool, and we add to it on a very regular basis. We've added 16 new functions in the last 4 releases. And in addition to that, we've also modified a load of existing functions, as we'll show you a little bit later on in one of these example sections. Go to that. Let's go right back to the beginning and talk about the basics of expressions. And these are the 2 fundamental questions we want to start with. Well, what are expressions, and whereabouts do we use them in the software? So for those of you who haven't seen it before, the easiest way to give you an analogy here is to think about Excel. In Excel, you've got cells in a spreadsheet, and you've got a load of functions that you can then use on those cells within the spreadsheet. And that's very much exactly how the Apteco expression language works as well. They work on a record by record basis. So if we have, for example, a record by record information here about the number of people within our standard training holidays database. So for those of you who are unaware, that holidays database has information on 1 million people and 2 million holiday bookings that they've taken. Here, each row is a person, and I have a number of policies and a number of bookings, for example. And a simple example of an expression we could generate from this is to do a policies to booking ratio, the number of policies divided by the number of bookings. That's not a field that exists within our source data, but we can use an expression to take those two fields and divide one by the other in order to get a result that we can then use within the software itself. There are 5 main data types that we have available within the expression tool. So numbers, both integers and floating point or decimal numbers, text strings, dates, date times, and the selector types. And we can have functions that act on each of these. And we'll see examples of that during the course of the rest of the presentation. Create in the expression tool are then used throughout the software, so we can make selections upon the results. We can add them as columns within data grids, and we can use them in cubes for analytics, either as a measure on the cube or as a dimension, as we'll see shortly. If the expression is one that we are interested in keeping hold of and using regularly, we may then choose to make a virtual variable out of it, which is basically a new variable that we can then use more quickly throughout the application. They're also used within people stage content steps. And not only that, we use these expressions behind the scenes to enable FastStats to work. So if you have, for example, a visualization such as a cube, and you select a cell and you drag it off to make a new selection, in many of those places, we will then use expressions in order to formulate the underlying logic that represents the people that were within that cell. It's used extensively in the segmentation tool for producing reports, either say the journey retention reports or the elapsed time segmentations. All of these use expressions to do that. They're used within the people stage reports for things like the ROI calculations and the like. And they're also used, for example, in the orbit Pareto tile, where we use cube expressions, which we'll cover a bit later on, in order to derive the functionality and the measures that we need to show the curves from the orbit Pareto chart. So let's have a look at some examples within the software based on, for example, in this first case here for a selection, we're going to try and select people who have made a booking and then traveled very quickly after that booking. We're going to show a cube measure and a cube dimension example. So we're going to have a cube of destinations, and we're going to look at how many days on average people will have between their booking and their travel for each destination. We'll also have a look and see whether the average cost of a holiday is affected by the difference between those booking and travel dates. And finally, we're going to develop an example in a data grid column where we're going to develop a salutation expression based upon titles and surnames. FastStats here, and I've already set up here a booking selection window for in a minute. On the right-hand side, I've set up the expression tool, which I've pulled down onto the workspace. And within this expression tool, we've got a list of the functions available to us on the left-hand side, and they're split into various sections. If I click on a particular section, such as, for example, the date functions, I can click and then choose a function in the middle here, and I can find out some information about it. If I double click on it, the text comes in here, and then it will start to build up the expression for me. And I want here to take the number of days between the booking and the travel. So I've got a booking date highlighted in my window. I can drag that across, drop it into my expression, and our logic will be building up and telling us whether it's valid. I know I need to supply 2 dates, so I can just, for example, drag those 2 dates across here and put a bracket in, and that will give me the days between them. So this is the difference between book and travel. I can just go to the icon, pull it up, drag it into the selection here, and if I say less than or equal to 7, this will give me the number of bookings that have happened with 7 or less days between the booking and the travel, nearly 150,000 bookings in this particular instance. We can make selections upon information that doesn't exist in our source variables, but we can easily create an expression to do so. I'm going to remove that, and I'm going to place a cube on top of this and look at adding this as a statistic into my cube. So if we imagined we had the bookings for each destination, and we want to know the average days between this for each of those booking destinations, I can drag my expression into the middle of my grid here. And because I've used the right mouse button, I get the menu, so I can quickly choose the mean. And I can now see that for each of these holiday destinations, the average days between bookings for each destination, and there's not much variation there across it. And we'll see this quite regularly through our data. This is fictitious data, so we don't often see all good trends in this particular data here. But on average, it's about 50 days between the booking and the travel, and not much variation between each destination. If we wanted to see whether the average holiday cost is affected by that average, then instead of dropping my expression into here, I could drop it over here on the dimension. So if I right drag and choose this, I can set up my bands. And I'm going to set here, based on the information I've just learnt, I'm going to say, split it into 4 bands in 30-day intervals. I don't want to see that statistic because that's no longer the relevant one. What I'm interested in doing now is having the average holiday cost in here. So this is the number of days between the booking and the travel. These are the number of bookings. This is the average holiday cost. In fact, even less variation than we saw before. So almost all of them are pretty much exactly the same. So in our data, no difference between the two. But hopefully you can see there very quickly how we can use the measures in both selections and cube examples. To looking at a data grid. Now, I've prepared some templates here earlier on showing me some information about some relevant fields. So here I have a title and a surname field. And what I'm going to do is I'm going to develop an expression that's going to manipulate the text within those 2 variables to create a new result. So in our function section down here, a little bit further down, we have a string function section. And in here, we've got another load of functions to manipulate strings, one of which is going to concatenate strings together. So our add_str function. So here, I could click on it, or I can start typing, and you'll see it starts putting color in as there. And if I start typing like this, I can start adding in fields, fixed text strings. And if I put my square bracket in, it'll allow me to choose my fields from here as well. And there, for example, I'm now going to create a new string, which is basically the title, followed by a dot, a space, and the surname. I'm going to call that salutation version 1. If I build that in there, you can see, for example, that it has pulled those 2 fields together and concatenated them nicely. And that works nicely, but there could be ways of improving that, because potentially the title might be unclassified or the surname might be blank. And in those instances, we may well want to do something where we actually have an if condition to say, well, if the title is missing, then we're going to return a generic customer. Otherwise, we're going to return the value that's there. And we can use the if condition, which is one of our logical functions in here, to say if some sort of condition is true. So if we had, for example, the title was missing, then I want to return a customer. Otherwise, I'm going to return what I had before. Now, I've shown you here indented and on separate lines. That's not mandatory, but it just helps explain what's going on. This is the condition we're looking for. So if the title is missing, we will return customer. Otherwise, we're going to return the thing we had before. So we could, for example, call that salutation version 2. And for the people that we've got here, we happen to see exactly the same results. But we would see customer for those who are unclassified. But again, we could even get further than that and say, well, if the title is missing or the surname is blank, then we can return customer. And we're not going to go all the way down that line. But hopefully you can see that we can build that expression up and gradually cover those more involved cases as we need to. I've shown you sort of the 3 basic cases of how we use our expressions within the selections, the data grids, and the cubes. Let's move on to something a little bit more advanced. And I've kind of put this in parentheses here about FastStats objects in expressions. And part of the reason for doing that is to explain that these are 3 particular things that we can add into an expression. And when we've done that, we will get a tab across the bottom that will allow us to show some properties and set some properties of those particular objects. So the first thing we will look at is the idea of an aggregation. And we can add one, or in our case in a minute, many different aggregations into the same expression. An aggregation is where we take a number of child table records for in our case, bookings, and we can summarize it to a parent table, in our case, the people. We could, for example, be the number of bookings somebody's had, their average holiday cost, where they last went on holiday, or what date it was, for example. And these aggregations are computed on the fly within expressions and then used and combined together with all the expression functionality to drive some fairly powerful pieces of analytics. Now, this on its own is an enormous topic. There are 10 different ways, 10 different types of aggregations that we've got available within the aggregation part of the expression tool. And I've talked about these many times before in previous focus groups. So back in 2017, we introduced the idea of these, what we call on-the-fly aggregations and expressions. A couple of years ago, last time we met in person, I talked about how we can use them to do pattern matching. And last year, we talked about the idea of grouping by a selector, so the category grouping aggregations and the kind of powerful analytics we can do for that. So if you want to learn more about those, you can return back to those talks and have a look at them. But the example I'm going to show you in this focus group is an example of developing a churn scenario, because this is one that we have used in our training courses before, and it's quite a nice example of ways in which we can use these aggregations. And the idea here is to look at how many days it has been since we've last booked, and then subtract from that the kind of average days between our bookings. And we can calculate that by knowing when we first booked, when we last booked, and how many bookings we had in that period to summarize the average. And then we can make that calculation, and depending on the value, we may then want to use that in some sort of marketing campaign. Let's have a look at how we can develop that in the expression tool. So here I'm going to start a new expression, and it's going to be a person level expression. And the aggregations are added through this tool up here. So if I click on it, it will add an aggregation, and you can see down the bottom here, we've added a tab. And this is the tab, what I mean by the idea of this object. We click onto it, and we can set some properties of that aggregation. Here are the 10 different types we can have. And the one I want to do first is to use the idea of a recency aggregation. So I want to find, when was my first holiday booking? Well, I need to order my transactions. So this is taking my bookings summarized up to the people table. I'm ordering them by booking from the earliest to latest. I'm selecting the first one, and I want to return back the booking date. And I'm going to call that first date. You can see in here, it's called me first date. Now, to find out the difference between the first date and the last date, we've already seen how we do that. So we've used that example already. So I want to take the date difference between my first booking date, and now I want my last booking date. Well, if I come down to my aggregation, I can copy it. I can change this from earliest to latest to earliest. I can choose this to be last date. If I go back to my expression and open the parentheses like that, I can select last date, like so. So that's giving me the number of days between my first date and my last date. And then I want to divide that figure by the number of bookings, number of gaps we've got. Well, the number of bookings, again, is an aggregation. It's here, so I can add a new aggregation, and it happens in this case to default the number of bookings we have. And the gaps between them, if I've got 3 bookings, there are 2 gaps, so I need to take 1 off of that. And that will give me my kind of average days between bookings. And I need to take the number of days since my last booking. Well, we happen to have a function called the age in days since my last booking. Well, that was the last date, and I can just subtract that figure. So quite quickly, we can develop a thing here with 3 different aggregations to have my churn scenario there. Results of how that's going to look with some example records. Now, I happen to have in my folder here some variables already. So I'm going to use here, show me people who've got more than 1 booking. I'm going to add my churn scenario expression to here and show people whose value is around 0. Then in my templates, I happen to already have somewhere up here an aggregations example, and I'm going to drop this churn onto the end. And then what we're going to find in here is we're going to select people here who've got, for example, the second person in here had a booking, 2 bookings, one on the 5th of October and the second one on the 25th of October. So there are 20 days between their bookings. They should have expected them to book again 20 days after that, which was 4 days ago. So these people here are 4 days overdue on a booking almost. So we want to now be thinking about sending them a message to say, well, you're looking like you might be lapsing, maybe you want to send some sort of retention idea. The people who've got a low negative number, we're not quite yet to the stage where we're expecting them to book, but there will be soon. So maybe we want to start reminding them of us and using these maybe in some sort of people stage campaign in order to sort of direct that marketing behavior. Okay. Turn back to the talk. So this idea of an object within an expression is the ability to use selections in expressions. Here we're taking basically the idea of any fast stats selection. We can then go and add that into our expression. And what will happen is we will compute whether for each person you would be matched in that selection or not. And if you are, we'll give you a value of 1, like a true value, or if not, a 0 value. And then we can do something with that. And the example I'm going to do here is to try and develop some sort of idea of a destinations visited scorecard. So visited Australia, I'm going to give you a score of 5. And if you visited Asia, I'll give you a score of 4, and for each of the other continents. And then we'll add them all up. And then when we've done that, we can then select people who've got a reasonably good score based on that metric. And that could have been achieved there in lots of different ways. But hopefully there you can kind of see, well, it's going to be people who are kind of going to lots of destinations, but we're not prescribing exactly which ones you're doing other than based on that score. Let's put that in action as well. So here, I'm going to start by creating the selection I want to look at, which is going to be this selection of people here. And I'm going to find and use the continent variable in my System Explorer. Okay. I'm going to choose Australia. If I start my expression over here, then I can simply drag an expression and just drop it into the middle of a query like this. And it will provide a tab here so I can see what that query is and a definition in the text here. And now I'm going to use my logical functions again to say, well, if this person has been to Australia, then they'll get a score of 5. If they haven't, we don't want anything to happen, so we'll just put a bracket. We don't need to put an else condition. And then we want to repeat that for each of the destinations. So I can now come back to my selection and say, well, if you've been to Asia, we'll give you a score of 4. If you've been to Africa, we'll give you a score of 3. And if you've been to America, we're going to give you a score of 2. Finally, if you have been to Europe, we're going to give you a single point on the end. We put our queries into our expression there, and now we've got a fully functioning destination scorecard expression. This query is now redundant. We don't need this anymore. And if I go to my templates up here, I've got an example of queries one that shows me the people and the continents they've been to. And if I call this my scorecard expression, I drag that into here, we'll see for the people that are there, some people, these top people have only been to Europe. These here have got 5 points for Australia and 2 for America, for example. If I want to select people who've got high values, I can simply add it to the underlying selection and say greater than or equal to 7. And then we'll see the higher scorecard people in there. And if I group by that scorecard, well, in that first 1,000 people, there are some that have got a total of 14. And the only way they can do that is by being to all 4 continents apart from Europe. And again, if we wanted to change the values for each of those continents, it would be simply a case of coming in here and editing the scores that are given to each of those continents. So that's the second type of thing that we can add to an expression. Is the ability to add a cube into an expression. So there is a restriction here that you can only add a single cube into an expression. And for each of those records within our selection, we will work out which value in the cell, which value in the cube you would have been in, and then use that in the expression. So for example, here is a cube of bookings by destination. And if the current booking happened to be to Australia, we could look up either this value or this value. And the advantage is that generally in an expression, we can only access information about that particular record whilst we're processing it. But the cube lookup here allows us to look up values for a wider population. And a common thing we want to do here is to do a comparison to an average. So we might know this expensive holiday, but is it an expensive holiday to this particular destination where the average may be higher or lower than the overall average, for example? So in this particular example, I'm going to start by creating the cube that I'm going to be looking up from. So here is my bookings selection. I'm going to drag a cube onto it. I'm going to choose a destination dimension, and I'm going to choose the cost. So this is basically the cube we've just seen in that slide, the average costs per destination. And in my expression, I'm going to make this for each of my bookings. I want to take the cost of the current booking, and I want to subtract from it effectively the average cost for this, the average cost for this destination. So I drag this cube across like this. It will show this function and a tab down here, which will look up the value, and we can choose which measure. So we'll look up the average cost for the particular destination that this cost is for. So that is my distance difference to my average. And if I bring up my cubes example here, okay, I've got the cost in there. I can add that expression in. So for example, for this record here, the cost of this France holiday is £780.34. And the difference to the average is 780.34 minus the 644.58 in there, which gives us the average difference to the average for this particular destination. And we're not limited to a one-dimensional cube. If the average price holiday cost had differed from year to year, we could have made a second dimension and done that by booking year, and then it would have looked up the cell in that particular destination booking year for us. So a very powerful technique there in order to be able to compare things to items outside of the current record. On and talk a little bit about some advanced data types. And in here we've got the idea of sets. And talking back to mathematics, the idea of a set is something with no duplicates. And in FastStats, we have that. We have the idea of a number of numeric values. So here is a set of numbers, and we often use this with a flag array of products that have been bought, where we will turn each of the products into a number, and then we can do some sort of functionality on it in an item by item basis. So back in 2020, we added 17 set expression functions, including the standard ones you might expect to see, mathematically unions and intersections and that kind of thing, as well as some utility functions for dealing with sets, so creating them, checking equality, turning them into strings, etc. Identify different types of customers. And although this is kind of a silly example, we're looking at people here who the holidays they booked in 2020 and the holidays they booked in 2021 and seeing whether they're different or equal or that kind of thing. And this is slightly perverse given the nature of the pandemic recently, that we won't have that many people who've done that. But let's see how this functionality works. We've got here an underlying selection here of people who have made a booking in 2020 and in 2021. And I've got in my thing here a list of all the destinations they've visited. So for example, this person here has been to entirely the same destinations in 2020 and 2021. And this one here has been entirely different ones. And they're very different types of people potentially, because you may want to choose to market a new holiday destination. Probably more sensible to market to the person I've got highlighted than the person that seems to be going to the same destinations year on year. And the way in which I've created these dests in 2020 and dests in 2021 variables, they are flag arrays here that have been created using the transaction summary wizard, which enables me to take a selector on the child table, in this case the bookings, and then flatten it to a flag array on the person table, which basically says this is the destinations that you have visited, and they're filtered in this case to the bookings in each of those particular years. We have a whole range of set functions down the bottom here, and the first thing I can do is I want to create a set, and I want to create a set out of the destinations that I visited in 2020. Now, at the moment, it doesn't like this because it thinks it's going to try and return a set, and that's not something valid to return from the function. I can use it within it. And if I put a function around this that says equal sets, in fact, if I spell it right will help, then I can create this with a number of sets on the end. So I can create a second set in here and say, are these two things the same? Again, if my typing's working this morning, and I can create a set out of the destinations in 2021. And there, for example, we're now going to say, are the sets of things the same? what I'm going to do is I'm going to place a cube on top of here for a minute, and I'm going to show you how many people out of that 77,000 have equal sets, and I'm going to choose all the people for whom that is true. And in here, it will now split this to no and yes. And there are 30,000 people who have had exactly the same holiday destinations in 2020 and 2021. If I wanted to look for ones that were entirely different, then I could choose to use the disjoint sets function in here. Call this disjoint. I'll add this to my selection down here. I'll remove the other one, and I'll call this disjoint. And if I right drag this onto this dimension, we'll build up a query set of those that are equal, and there are 32,000 people who had entirely different ones. So we've already got 62,000 of our 77,000 people in there who have been one of those two particular sets. And we could continue that example further by looking for those who had a subset and a superset or didn't fit into any of those categories. And that helps us to analyze, and then we can use them in terms of our marketing campaigns and treat them differently within the results. Let's move on and see something a bit different. The second type of thing that I would like to look at here is the idea of a list. And a list is basically like a set, but it can contain duplicates. They could be numbers, or they could be textual values. In this case, these are postcodes of the major UK airports. And I'm going to show you a development that's gone out in the last release we put out in Q3 2021, where we can pull a list together from a column within a file. And the idea here is that we're going to have a set or a list of postcodes, which are, in our case, airports, but they could be store locations or retail points or points of interest. But because we're bringing them from a file, then we'll be able to cope if they change very easily without having to adapt the expressions. Okay, so let's have a look at, oh, hang on a minute, let's just show you this in example here. So here we've got, for example, for each individual person, find me the shortest distance from there to any one of my UK airports. And we can do that using an expression. And this is a UK postcode expression that looks between my postcode and any one of those to find the shortest direct line distance. That expression is then copied around and used within maybe a data grid, in a cube, in PeopleStage, for example. And that text is just copied across and used. And it all works beautifully until maybe a couple of years later when we decide to open up flights from Glasgow Airport. And the problem is then we need to go and adapt that expression by adding that new postcode in. And we need to find all those other instances and update them. Otherwise, it's not going to take account of that new postcode. So what we can do now is have, for example, a file in the middle of here that has my 4 postcodes, and that all works beautifully, because I can now use this text list from file function to basically take a list of postcodes from the second column in that file. And then when things change, I just update the file to include Glasgow, and all the expressions will just work as before without having to change anything. Let's have a look at that in action. And to show you this working, I'm just going to take a representative and geographically dispersed set of people by taking one person from each postal area. So I'm going to take one person from each postal area. I'm going to place my lists from file on top. And in here, I already have that expression from the open-ended lists here. So I've got, if I view this expression, this is what we just saw in the slide. So the UK, the postcode dismin, but here are my 4 airports of choice. And I can replace that with a text list from file. And this file will be existing somewhere within your system. So in my case, it happens to be in my private data files directory and will be in airport postcode.txt file. I know it's in the second column. There are no header rows, and I know it's comma separated, and there's no enclosures. Some of those parameters are optional. So if I change that to be from file and drop this into my expression, then what we'll find is that it's run and it's given us exactly the same values throughout. Not too surprising, because my file's got those 4 same postcodes in. But now, if I change this to put Glasgow in here, okay, and there's the postcode for Glasgow, and all I need to do now is go to my file menu here and save that file. And if I come back up here and rerun it, and what we're going to see is that for some of them they're the same. But for some here, like this postcode in Scotland, It's no longer 385 miles from Manchester Airport, it's 192 miles from Glasgow Airport. Okay? We've made no change to the expression, we've just gone and taken the new information from the file there. In the geographical expressions, we've adapted lots of functions which could take any number of parameters at the end of them, and we can now pull them from lists. So, for example, if you had an external list of products you wanted to match, then you can might have a list of destinations, and you want to say, well, is that person's last destination same as one of these 3 destinations that we're interested in, and that come from this particular file? Or you could, for example, use some sort of analytical result that you've output through a scheduled task into a file, and then use that as input into another file. And we've done that, for example, in 2 or 3 cases, and we will show you those in an upcoming blog about how we can use that quite nicely to even bring information from one FastStat system into another, for example. The second type of way in which we can use expressions in things are in the idea of derived cube expressions. And this is very much like Excel. So if you went back to the very Excel example we looked at earlier on, and if we had this FastStats cube you see in the bottom right, and it was in Excel, these would all be cells within our resulting sheet. And then we may want to get together, say, a bookings to person ratio. And you'd do that using an Excel formula. And we have kind of measures in FastStats itself, and they're the calculated measures, and they cover a lot of the common use cases like calculating this ratio. So, for example, here there is a relationship between bookings per person as we go through the income bands. And they work really well for ratios, for ranks and comparisons and the like, except when they don't do exactly what you want, because they don't allow you any flexibility. You pick and choose the items, but you can't change them. So we've developed a different type of expression here, which can reference cells and ranges in cubes, and then use the whole power of the expression functionality to basically give you that flexibility. And I'm going to show you how we can use ranking across a given dimension in order to show the power of these expressions. In this final example, I'm going to take a cube here, and I am going to add into it a booking month variable in here. So I'm going to call this, for example, month. And this is going to be the number of people that have made bookings in each of those months. And if I wanted to get a rank for that, I can use the existing calculated measures functionality here. I can choose rank, and it will basically start by choosing a dimension. There's only one month, there's only one people in descending order, and it will use the competition strategy for breaking ties. And you can see there we've immediately got a rank functionality. Expression. So we can start by building up the expression, and it works very similar to the Excel equivalent rank function. Here I'm going to rank my list, and the value I want is for each cell in my cube. So we have to say for this cube, which measure do I want? I want the people measure. I want to go in descending order. I want to use the competition strategy for breaking ties. And the range of cells I want is everything on this particular dimension. And I have a cube range functionality. And I can say on the current cube, for that measure, what I want to do is I want to return all the values on that cell. And the syntax for this is to say all of the cells on this dimension is done by that particular combination. And again, our help documentation will give you information on how that all hangs together. And if I call this rank all, and I drag this on the cube, this will need to be calculated because it's not being calculated client side, it's being calculated server. But we can see there that is the equivalent expression to that calculated measure. But if I wanted in the rank this month, basically, what's its rank so far? Well, we can't do that using the calculated measures. But in here, I would just need to change that to a plus, and it would say up to the current cell. So this will now give me for every cell the rank so far. So for this cell in June 2016, it's got a rank of 4 because it's the 4th biggest that we've seen so far. This is also the 4th biggest we've seen so far, etc., etc. And if we wanted to return, for example, the rank in each calendar year, we could change this function to a date period cube range. We just now need to say which dimension, so it's a month, and we want to say within the year it belongs to. we have the rank in the particular calendar year. So they're the first, all the ones in 2016 have got the values 1 to 12, 2017 similarly. So hopefully that gives you an illustration of how powerful those expressions can be for generating very flexible results. Okay, so that's all the examples I have to show you, but just a very quick sneak peek into some stuff that might be coming up in 2022. We showed an example earlier on distance-based expressions using the UK postcode distmin, or there are equivalent ones if you've got latitudes and longitudes in the geo functions. We often have equivalents for finding out which was my nearest one, so which airport was I nearest to, either using postcodes or latitudes and longitudes. But that can sometimes be a problem if you've got, say, mountains or water or other features in the way that where actually you want to find drive time as being an important thing. So back in early part of 2021, and James showed this on the main stage, we had this geopointing area function, and that allows us to select points and shape the map exactly. Now, James showed you a scribble on the main stage yesterday, but it could also be done by doing a drive time directly on the map, dragging out to our selection, and then we can select people who exactly live within those points. And that works quite nicely in this instance here. But I'm going to try and develop some sort of expression that looks a little bit like this. Give me my drive time from the postcode I belong to the postcode here for Heathrow Airport. Or maybe you have a number of locations like our 4 airports and want to know the minimum drive time distance, or maybe even the nearest one to those. So it's unlikely we're going to end up with any syntax like this, but this is kind of a nice, easy way to show you what the end result we're looking to achieve is. And currently in the R&D phase, we have examples like this working, where this is a map where each of these layers is the same selection. That selection is working on an expression to show you the people within 5, 10, 15, 20 minutes drive time of the Apteco offices. But we're not using any of the results here from any of the existing mapping wizards. We are calculating kind of drive time boundaries there to the 5-minute intervals. And the final example here is to show you the drive time min, or the nearest. So here are a load of people who are within 75 minutes drive time of one of my 4 airports. And then I've categorized them into the people who are nearest to each of those airports. And again, they're running off an expression, not the results of any VVs or anything like that. Or we could create VVs out of them, but they are running live off an expression here. So if you take the Birmingham ones in the middle here, for example, there are people up here who are much closer in a direct line distance to Manchester Airport, but it's easier for them to get to Birmingham, for example, because the M1 comes down across here, whereas it's harder to get across the Peak District. So this is just a sneak peek to show some work we're trying to do at the moment to make the ability to do drive times type calculations in expressions, but more on that hopefully at some point in 2022. So very quickly to finish up with, if we're looking forward to what happens from now on, well, we added 16 functions in 2021. Do expect regular new additions. If you come up with analytical challenges for us we can't easily solve, maybe we'll add new expressions to solve them. In Orbit, if you want to use expressions, well, we support them fully in the API layer at the moment. If you want to use them in any of your dashboards, then you need to create a virtual variable in FastStats first to be able to use them. But at some point in the future, we will allow you, I'm sure, to create expressions within the Orbit platform, but not yet. And finally, to point you in some directions of some resources, we just had a little bit of context help alongside the functions we saw, but there is full online help available with lots of information, all the 200 and so functions and the types of things that you can add to them, as I showed you. There is an expression user guide on the Apteco portal. And within the new Learning Hub, there is now an expressions course and some videos on some of the topics, including a much longer example of the churn scenario I covered earlier. There are also blogs on our Apteco website, a dozen or so on different expressions and aggregations, which kind of show some of the holiday use cases that I've described today, and also take these techniques and use them on publicly available data, usually to crunch and find interesting insights on football data, for instance. So if you have any questions on expressions or any other analytical topics, then please do feel free to email me. That's my email address after session. I would love to hear from you. Tim, I don't know if we have any questions on the chat or if we have time to do so, but how are we placed there?
Yeah, we need to rejoin the main session now. But there's been quite a few questions that people have sent directly to me, which I'll make sure we get back to those people after. We'll get their email addresses and reply to them.
Brilliant. Okay, so thank you everyone for attending the session. We will get back to you on the questions that are in the chat that we haven't answered so far. If you could rejoin the main platform, and then James will be concluding the conference very shortly. Thank you very much indeed for your time. That's it for now. Bye-bye.